So in the previous slide, we tried to explain from the camera coordinate transform to the ground coordinate, and so as to get a point cloud or 3D information one. Okay, so in this image or in this slide, he's saying showing two-way describe to deal with a stereo-based 3D information. Okay, one is for point cloud, represent a 3D Cartesian frame with a ground coordinate, and the second one is a 2D W density grade. Okay, yeah, so we can using these two method. One is a 3D and the other is a 2D one. 2D is using a density grade, so therefore you can see there's a different intensity for the grade, different grade level. So for here you can see there are different weakness or strong. A strong one is a higher density one. A weaker one is a lower density one. Okay, so that's 2D. And 3D, he just let you see a more dense, a more cloud one is we call a point cloud, like this one. And a point cloud is a collection of many small data points. Okay, and this point exists within three dimension. So each one have a x, y, and z coordinate. And this, of course, this point represent a portion of a surface and within a certain area. Okay, yeah. So we can think this point is similar to a pixel within a picture. So once the entire space or landscape has been measured, the point cloud can be used to create a 3D map or a CAD model. Okay, computer-aided design model. And point cloud can also be collected using photogrammetry, such as the multiple photo taken from various angles to calculate the point. So here is an example showing the point cloud of a chair and a point cloud of a tree. Okay. So here is an example for research to create the 3D model for tomato canopy, and using the a portable scanning LiDAR one. Okay, so the first image is showing the canopy of the tomato, and the second one is showing they measure by using this kind of device, the portable scanning LiDAR at three positions: position 1, position 2, and position 3, to get three different angles image. And after that, we will join this information together and create a point cloud. And here are showing once he finished the point cloud creation. And so in the figure 3, a 3D point cloud image of tomato canopy obtained by a high resolution LiDAR. An example of polygon leaf image made from a LiDAR drive point. Okay, yeah, so here is a tree and with his leaf, and figure 4 is a cross view of a point cloud image of certain leaf. So this is a leaf, okay, and this leaf he will using some a curve fitting technique or equation fitting technique to get his corresponding polygon image. So the right hand side, this one is you can see the point has been connected using the line one by one with his neighborhood joined together. So by this way, we can get we call a polygon leaf. A polygon is like this one. Okay, I'm drawing a polygon. Okay, so a polygon is a similar shape which with many edge on the shape. So figure 5 comparison the leaf area estimate from the LiDAR drive polygon leaf image and the actual leaf area. Okay, so here is the actual one, and here is our estimated one, and you can see their point fall on very close to the the 45-degree line, and which means they are very consistent to each other. Okay, he actually is 20, and you estimate is around 20, so the point is around here. Okay, and so that the error of for this point, and he gets the mean absolute percent error MAPE is around 4.6 percent, which is a very good one. Okay, and for our point cloud or 3D model on the on our crop, and we have a different level application. One is from a big a broad view. One is from the prod level and down to individual level or leaf group level, and the final one is the organ level. Okay, so for the prod level one, of course we can segment this into a small plot. Okay, and for the individual one, we can separate each crop. Okay, and so you can see one by one is like this way. Okay, and if we go deeper, and we can separate the leaf and the stem. Okay, so here is the stem, and here is the leaf. Okay, so we can analyze them. Okay, and in the organ level, we can, for instance, here is a stem. Okay, and we can just get more detail. So for analyze the just individual one, a specific leaf. Okay, yeah, by this way we can get a very good information on the leaf. So you can see this is a purple or pink color one, so it represent in the leaf of this one, maybe a fresh leaf, and he represent the virus or some the health condition for this crop. Okay, so they are all we call the phenotype typical trait. Okay, yeah, so this information is very important to farmer as well as to researcher. Okay, so Phil measure the biomass at plot, individual leaf group, and the organ levels. And maybe he were using simple linear regression, a log transform simple regression, stepwise regression, artificial neural network, random forest, and finally he will find the best model selection and variable importance analysis. Okay, so I stop here.